Friends, today we are here and today we are going to talk about like AOA, which is one of the best subject for my engineering, and sometimes like it gets hard, but right now like I'm preparing for my exam, so like let's go through some beautiful note which is created by my one friend, and yeah, so totally all stuff which will be provided by him. So just short out the game and let's talk about it. So the this is analysis of algorithm. What we actually do in this one particular subject is like every person, like uh, let's say every data scientist or data analytic, they have to understand about this one particular stuff, which is like how, like if you're making some problem, if you're making some software, so you must be knowing like what are the algorithm you should use, like as a machine learning model, or you are training something else, so you must be using like uh, the technology which will be having less time complexity, and that should be much more effective while whatever the students are doing. So this is the basic thing, right? So why do we study analysis of algorithm? Why we analyze the algorithm? So the basic thing which comes into the picture is like how the algorithm has been scheduled, and how we can analyze that, right? The time complexity. So we'll just go through this all this stuff. So the very first thing is introduction to algorithm. What is algorithm? Now it is a finite step to solve a problem is called an algorithm, right? Analysis is a process of comparing two algorithm with respect to time and space. Now, as I told you about this, right? So these are the two, like how did we actually make the difference before execution, after execution, giving you approximate value, it gives you exact value, independent and dependent on hardware, right? The this part. So the very next thing and the best thing comes like what is asymptotic notation? It is a mathematical representation of way of representing the time complexity in which like we actually represent how the time is actually going on, right? So in this you will find like big omega, big theta, right? So these are the basic time complexity. So you will see like big omega is the best case, and whereas the big theta is an average case, and big O is a worst case. So you will see like how by the time like we will make this graph, which make the difference like upper bounded, lower bounded, and exact time. So this is how we will get the time complexity as well as the space complexity. You just go through this one particular stuff, and these are the some basic questions like which we are actually trying to do and trying to manipulate that, like big omega. So like let's suppose like they have given us one function, and we have to find what are the best case, worst case, or any other cases, right? So what will be my very first step is I will write 2n square plus 2n, which is less than equal to something, or which is less than equal to another thing. So like we will compare and we will just actually what like how the things are actually what will be the best case for me and what will be the worst case for me. So then I can easily able to choose which algorithm should I use for this particular task, which algorithm should I use for this particular moment, which part should I use for to getting a better efficiency. various properties of asymptotic notation. The very first one is reflexive property, symmetric property, transitive property. You will see these are the basic thing like big O, which is less than equal to function and constant value, big omega, big theta, small theta. These are the basic asymptotic notation that which we actually represent. So you will see like this is the basic. You can easily take a screenshot or you can take have a this in your mind because it will help you a lot. Like reflexive property, symmetric property, transitive property, a big omega, like what are the condition it satisfies. Big omega, big theta, small omega, small theta, right? Yeah, we will move further. Comparing the various time complexity. So here, like you can see this one particular graph in which we will see how we are going to compare that particular. You can see this like the very first case of time complexity is big of constant, and this is how like the n log n log n, then we go of log n, we go of n n raised to half, we go of n log n, and this is the very much worst case and best case you will find from it. As you go deep down, you will understand it much more thing. And the time complexity for all searching and sorting algorithm, time complexity for all searching and sorting algorithm, binary search. Binary search, do you know? Like, we'll go through that. What is binary search? What is sequential search? What is quick sort? What is merge sort? What is insertion sort? 15 puzzle, doing many more things like many more algorithm, driving salesman. These are all the basic images or these are all the basic thing like which we can go through while studying this one particular stuff. We can just take a screenshot of all this stuff like yeah, binary sort, selection sort, quick sort, merge sort, insertion sort, heap sort, height of complete binary tree, which is we go of n log n insertion, and heap, which is log n construction, heap n log n, delete from heap, yeah right, Hoffman, Prim's matrix, Kruskal, DFS, BFL, depth first search, and breadth first search, all pair shot, DJ's custom. Once again, you can go through these some sounds like I will actually teach you all these sounds in another video, but right now we are just going through it. personal relation, which is typically step chapter 2, or we can also see here and find the module, right? And once you get that module, then we can easily able to this is my math stuff. I will just show you the university, right? Like so, right now, like we have done recursion on performance of analysis on the space and time complexity, growth of function, we go, right? All these we have done right now. Complexity, which is defined by P and N, P and N B, recursion method with the recursion tree method, master method, divide and conquer approach, greedy approach, in which like in divide and conquer method, we will find that the general method, merge sort, quick sort, finding minimum and maximum, and algorithm with the analysis. Like in analysis, like we have to just provide them with a pseudo code as well as we have to tell them about like yeah, in this like you can find it like if we tell you like you have to do this analysis, so then you have to do show them the time complexity about this minimum, this maximum, like while you are doing it. Analysis the binary search. This is also one of a good algorithm you can say. Yeah, yeah. So that's how like we can go through that. Then we will go for greedy method and greedy approach, English like next net problem, job sequencing, deadlining, minimum cost, spanning tree, Crucible and Prism. Like these are all the basic algorithm which you are going to learn, and it is pretty much simple. I think like every person should know about that. Dynamic programming approach, general method, multi-staging, graph, single goal, short path, Bellman fold, all pair, fluid option, assembly line, scheduling, problem, map snag, problem, traveling salesman, LCS, which is longest common subsequence, backtracking. So let's continue with that. Yeah, so we were on this particular page and binary search you will see. You will see like in binary search, like first we have to they will provide us with this particular things. Like I will draw it for you. So they will just give us this particular thing, and we just have to include this one particular stuff, and we will give it all the particular, let's say 1, 2, 3, 4, 5, 6 and 7. These are the index. First we are going to add like first index as well as my last index, and 1 plus 7 which is 8, and 8 divided by 2 which is directly come to the fourth point. So we will divide this, and the very left side will have all the smallest element which is less than 40, right side which is all the element which is greater than 40, right? So once we get that, then we are dealing with this actual pseudocode. Like first, what we are going to do first, we'll have this binary search, in which like we will assign four variable, yeah, four variable in which the very first like we will add and subtract and divide by 2 as I told you to get the minimum midpoint of that particular array. And then after we just complete that one particular step, then we will check the if a of max which is equal to x. So what is x right now, which is the next step. Like we will compare that one particular thing. Like if it satisfy my condition, then we will return this midpoint, right? Else, if a of mid is greater than x, x what is not 30, right? So we will combine. Yeah, it is right. So then binary search is a comma I, which is mid minus x, right? So what it is like a? What is my a? Now you will ask me a midpoint of my array. Just go through this sum. Like this is also a recursion sum. So what we are trying to do in this, like they have just given us like t raised to power n and plus c, which is less than equal to n. And yeah, so like at the very first time, what we are going to do is tn, which is less than equal to 2 and plus c. So now, have you just taken this substitution method used to solve the recursion relation? In substitution method, like we are just adding or subtracting the one particular index or with one particular number from that same point, right? So you can see this. This is quite beautiful. Like what they have given us this particular statement, and we have taken consider it to a tn. Then we will have one which will be less than n minus 1, and then we will add these, not this, wherever the n will add, we will add the n minus 1. We will get n minus 1 into d raised to n minus 2, and then so on. Put the equation in 2 in 1. So then once we are substituting this, we will get this whole number of things. The very next question, we'll just go to this. Now you can see the next question. I think you can stop the video. So, you will let it go clear about that. You just take it very slowly. What is most method theorem? We can we can't apply most method in all the recursion relation. It can be applied only to a certain form. So, like somewhere, uh, you can't apply substitution ownership into most method. You know what is most method? And most method, like we are just trying to make it more feasible, make it more easier calculation. You see, like how we have done this. So it is a very easy algorithm insertion short in which they divided the main array into two different parts. The very first part, which is known as sorted part, and the next part in which the elements are arranged randomly is called unsorted path. So just to compare the first element with the second index or first index, so if you see like if the condition satisfied, if our first index should be less than or equal to the next index, so once this condition is satisfied, we will just add that number to the very next thing, like as we can see here. Then we'll go to another element and we'll compare that another from that same element if it is greater, then we will shift that one element to one certain position where it where until the condition gets satisfied. With how we are keep going with the sorted and unsorted, which is all get started. In session short, you can take the first time it is sorted and the next step we can compare it with them. next time. This is the same thing like which we had just now study about it, and after a repetition of one times, you will find all the terms are completely with the same stuff. This is how like, we will write our single code. First, you are going to declare a variable, then you will make one extra variable in which we can store the value and we can swap that number between one number to another number. Print element of another like you are going to print and printed at the end for like we are just getting the range in that one particular field. So without this, we are just reaching the we are just changing the number from weightage to another from a sorted list to an unsorted list. Selection flow. Selection chart is not that different from the insertion chart, but it is different. So it is different. But in selection chart, what we do, we take the very first element of an array and we will compare and see uh, the any number which will be less than or equal to that element. So once you find that the smallest number in my array, then I will swap that one particular number with the first number. You'll find it will be much more easier. And then once again, we will increment one position and we'll have that second, and then we will come back everything in a most smallest number in an array. Then again, we are going to swap. Then we are going to come on a third index, second index. You can set the index number starts from 0, 1, 2. Then again, we are going to search for a very smallest number. Then we'll find it, we'll swap it. We'll find it, we'll swap it. We'll find it, swap it. When we are going to do this third thing, the we can say the array must be short. Yes, we have to interchange the item with the smallest number. What is divide and conquer? Divide and conquer rule is a basic problem in which like we actually divide the main array or main task into a small subtask. Let's take an example of a real life. Like once you get a big problem, so what we are trying to solve that big problem one by one by giving it to someone or by taking it from someone. Just dividing one by big job. Like uh, right now, I'm with my team and we're working on some data mining projects. So we have got a very big problem statement and we have to divide our work and we have to do it right now. This is how it actually works. This is how we actually do
That's right. In this, we have a big array. We are dividing that big array into a small sub-array till when it is just remain by one element, and then we are just sorted and we can find it again. Okay, so so you can run this example, you can try this by yourself. So you can want it, which is that we have to have the very first element is a private element and the next one. Or even we are considering it a PO, the last element we are considering as a queue. Then we can do this, like we can also have a private element which will be 45. You can either solve from either left or right, it is up to you. So once we have this 35, and then go from if it is greater than the next number is greater than 35, yeah, it is true. It is less than 35, no. It is less than 35, no. 90 is less than 35, no. 20 is less than 25, yeah. But then what we are going to do is swap the P and Q with each other. So you will see how these 50 years in here, at the 20 and 20 years will come here. So, right. So, we are here, we have just made the date changes. So, let's see, this is my new thing, which will be less than 34. Yeah, it is less than 34, less than 34, yeah. Less than 35. Pass. With the injection, I think this is a very large part of stuff. Only the maximum. Like again, we will do that same thing. We'll divide the bigger into a small subset, and we'll just finding the meaning and maximum of what each particular term, and then we are going to compare the maximum from that thing, and then we are going to find the actual meaning and then actual maximum value. In short, this is also in short recursion and ingredient following the function, rearranging the brand. And it's a problem, this wonderful problem that we are going to talk about it in a very next video that we about the alternative. So that's all from my side. Thank you.